The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome. My name is Eric Coleman with IIST and I'll be the moderator for today's webinar, Risk-Based Testing, Analysis and Strategy Development by Clanese Cheney. We're excited you're able to join us today. Set aside an hour to attend this webinar. This webinar is one of a series of free webinars to introduce the topics as well as the presenters of the upcoming PSQT conference in San Diego, California, August 14th through the 19th at the Sheraton San Diego Hotel and Marina. PSQT is the only conference that focuses on practical best practices in every aspect of software quality assurance and testing. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To learn more about this exciting conference, please visit psqtconference.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at psqtconference.com. At the end of today's webinar, you will be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Clanese Cheney. Clanese?
Hello. Welcome to Getting a Handle on Risk-Based Testing. So we'll be basically talking from three key topics today. One, understanding risk from the software testing perspective or the product perspective. Then we'll talk about assessing those risks, again, from the product of the software testing perspective. And then finally, how to take that information about the product risk and then use it in a risk-based testing strategy. So when we talk about testing in the real world today, I don't think I have to mention to most of you about the increased demands for getting the product tested quicker, faster, getting the results as soon as possible. So what we are facing is that balancing act, and the balancing act, we've always had a balancing act in testing, but the balancing act today just seems to be having us running a little bit faster on that treadmill. So we're all experiencing short deadlines, limited resources, and we're still balancing, I wouldn't say poor quality, but we're having variations in our quality in terms of what the product is expected to do and our ability to actually deliver that type of quality. We're facing testing bottlenecks, and we're also facing issues with controlling execution of the test results. And so all of these different factors are what we have to balance in terms of being able to get your product out of the door in the time frame that you need. So in order to address some of those issues and address the balancing acts that we have, one of the things is to consider risk, not risk from the perspective of project management, but risk from the perspective of testing. And so what you see on the screen right now are the two concepts that I'd like you to consider when we talk about risk and risk testing today. One is the concept of risk-based test management, and the other one is the concept of risk testing strategy. So when I talk about risk-based test management, I'm talking about as the team leader, as the test lead, you're managing the testing part of the schedule, the ability to plan the testing, design the testing, execute the testing, and deliver your reports. So how you are managing them from a test perspective, from a risk perspective. And so what we're saying here is that you need the ability to manage not just the testing activities, but you want to manage them from a risk perspective so that you are able to report to the project manager, to your direct leadership or management from a perspective of these are the risks that are hampering my ability as a test lead or as a test manager to deliver the testing part of that schedule. The other concept is then a risk-based test strategy. So here we're talking about testing. The activities that I mentioned before, we're talking about project management from a risk perspective of the testing activities. But here we're talking about taking a look at the product itself and then looking at the areas where it could potentially fail and then writing a test strategy designed to actually identify for you whether or not that product is potentially going to fail when it goes into production. And so these two areas, risk-based test management and risk-based testing strategy, are what I consider managing testing from a risk perspective. And the focus today of the class on the bottom button, risk-based test strategy. So we won't be covering much about managing the testing activities from a risk perspective, but we will be focusing in on how you take a look at the product itself, identify areas where it could potentially fail, and come up with a strategy designed to give you information about the possibility that that product would fail or not. So in order to do that, we need to think about risk in general and define them and look at how you would go about.
Yeah. Clenis, if I can interrupt you just for a moment, we are hearing some clicking, what kind of sounds like keystrokes. I don't know if there's something clicking on your microphone, if you hear that or not.
I did not, but I will. Yeah, there's no keystrokes going on, so I will check and see. Maybe it's my hands that are actually touching occasionally the table here.
I'm hearing it actually right now too.
Oh.
So I don't know if it's maybe your microphone needs adjustment a little bit.
Okay, I switched the mic out. Is that better?
Yes, I don't hear any clicking right now.
Okay, all right, I'll switch on the mic.
Thank you.
Okay, sorry for the interruption, but want to make sure you have clear reception here. So when I talk about trying to identify risk, I look at them from three perspectives. So I look at risk from the perspective of the activities that are occurring on the project, and so those are what I consider process risk. So this is where you would look at how work is being done. So if on your project you have poor requirements processes, you have inadequate change management processes, all of those processes potentially have the ability to impact your ability to get that project done effectively. So that's how the work is being executed or done on the project. So all of those processes, a lot of them are the software development lifecycle processes that underlie getting effective testing done. Then we look at project-related risk, and those are risks associated with how the project is managed. So if testers are involved really late in the software development process, or if the dates that you're given for testing or the duration or the time is mandated. It's not a schedule that you come up with based on looking at the scope of the project and doing an estimate. So those are project risks that are, again, management-related activities. And then we look at what's going to be the key focus of the class today is product risk, risk associated with the actual product that's under test potentially failing. So when we look at these three types of risk, the focus today is on, let me go back, the focus today is on the product risk at the bottom. So how the work is done and how the project is managed, those risks, those fall under the button that I just talked about a few minutes ago, risk-based test management. So if you're doing an effective job of managing the project and process-related risks that impact your ability to bring that schedule in, those are process and project-related risk, and they should be managed from that perspective. But product risk, whether or not the product could potentially fail, and identifying those areas that the product could potentially fail, those are related to a risk-based test strategy, and we're going to identify them and then come up with a strategy specifically designed to address those risks and those concerns. So how do we do that? We do that using a risk-based testing process. And so when we talk about a risk-based testing process, we're trying to look at a process that helps us figure out when to stop. When to stop testing has always been an ongoing problem, issue, question that all of us in testing face. And typically when we talk about when to stop, we either stop testing either because all of the planned tests that we had planned to do are completed, either all the incidents that have been raised based on the testing that we've conducted have been resolved, or the ones that are planning to be resolved have been actually fixed, and we have verified that the fixes are in place. A lot of times defects that have been identified, again, have been fixed and retested. And again, we understand that there's some negotiation going on in terms of which incidents that we raise actually get fixed and which defects actually get addressed within a particular release. Or it could be that there's a series of regression tests that need to be run without failure. But in general, these typical kinds of activities are what most of us are using to base whether or not we should stop testing on. And there's always the one you just plain run out of time, but we're not going to put that up there. But that is often a reason why we stop testing. But when we talk about a risk-based testing process, we're going to have some slightly different questions and answers that will help us to make the decision on whether or not it's time to stop testing, or could you stop testing. So one of them could be, if we were to stop testing now, what are the risks that remain open? So if you've identified areas in your product that could potentially fail, and you have not been able to execute all the tests that if they pass will give you confidence that that product area won't fail, then you would not want to stop testing then. Or if you are stopping testing, then you would be able to provide the information about what those remaining risks that are open says about the product, and let that decision on whether or not they want to proceed. I also like to associate benefits. You know, almost all software releases have some product features or some benefit that the customer is hoping to gain from that release. And so if you've associated those benefits, you've identified them, and you've associated them with product areas or risk areas, then you can also be able to give information about the benefits that are now available based on the testing that has been concluded to date. So another question could be, if we were to stop testing now, what benefits would be available, or what benefits are readily available from the perspective of we no longer have concerns about them failing in production, and have sufficient benefits been delivered or realized at that point? Are there any critical problems or risk that remain? And that's different from the notion of we've got these open defects that are remaining, maybe high priority or high severity type defects, but we've identified certain risks, we are testing to those risks. How many of those risks remain open or unanswered at this perspective? And at this point in time, do we have enough evidence to support making a decision on whether or not we should stop testing, whether or not the product is ready, based on what? Evidence from your risk-based testing strategy. So I'm not saying that we don't run out of time in testing. When you're doing a risk-based strategy, we can run out of time. But if you've employed a risk-based testing strategy and you've implemented it effectively, typically in those kinds of scenarios, if you run out of time, all of your high risk or most of your high risk areas should have been addressed, because the focus of the testing wasn't done based on this is how you actually go through the code, or these are just 200 tests and we're going to execute them in some random order, but you're executing tests based on what? The identified risks that you have for that associated product. So that's what a risk-based testing process will do for you, and that's what we're hoping to provide you with some information about how to do that going forward. So when we talk about a risk-based testing process, you have on the screen a risk-based e-business process by Gerard and Thompson. It's actually a book, and it is titled Risk-Based E-Business Testing. It's an excellent source for helping you to understand risk-based testing, and one of the things that I really love about it is in the back they have lots of identified risk for web-based applications, so you don't even have to think of all of the risks. You can go in and pull out their list of identified potential risks that are categorized. It's a very helpful, practical book. But in there they identify 5 different steps in risk-based testing process. And if you have taken project management somewhere of the steps seems familiar, and that's the good news, is that we're not coming up with anything totally weird and different. We are applying the basic tenets of risk that you use in project management, and we're just applying it to a testing project with some slightly different alterations or modifications for testing. But in general, this is the standard risk management ideology and process that most of us are comfortable with when we look at project management. So step one is risk identification. So from a product perspective, from the application that's under test, we want to identify the risk. And it's very similar to what you do in traditional risk management and risk identification scenarios. You're going to come up with potential risk, and you're going to be looking at the business and technical staff. You're going to be coming up with a potential, what I call a draft register of risk. So these are your potential areas that you think the product could fail. We're going to talk in a few more slides about how to get that potential list of risk. So then step two, once you've identified the areas in the product that you think are prone to high probability of failure, then you do some analysis. And so you're going to be discussing those risks, and you're going to be assigning a probability or chance of it occurring, and a consequence or damage or impact or harm should the product fail. And then you're going to calculate what we call risk exposure or your risk ranking. And again, this is no different from what we do in traditional risk management. So we identify not project risk, but we identify product-related risk where we think the application could fail. Then we analyze the risk using traditional techniques, assigning probability or likelihood of it occurring, and associated or harm or consequence rating, and then we calculate it, and now we have a risk ranking for each of the area of the product or component that's under test. Then this is where in step three we really see the difference between traditional risk management and risk-based approach in terms of software testing. Instead of doing a traditional response, typically the response to identifying and analyzing your risk, you've got them in a ranking, you typically come up with a mitigation plan, some kind of approach to either keep the risk from occurring or to reduce the harm or damage or impact that the risk can have. That doesn't really work for us in testing, so we're not going to be writing mitigation plans for we feel that the product could fail in terms of security or in terms of it's vulnerable to penetration from hackers. But what we will write is specific test objectives and identify specific test techniques associated with that particular failure point. And then we document the dependencies that we need in order to execute that particular test objective and test techniques. We come up with time frames and time scales associated with how long will it take us to execute that test objective. And if it's sounding like a test plan, then you're right on target, because the response to identify product risk is pretty much coming up with a strategy for actually coming up with tests that you want to design to give you confidence that that product failure may not occur in production. And so step four then is you've identified your risks, you've analyzed them, you started formulating what your risk-based testing strategy, and so now you want to take a look at that strategy and you want to agree with the scope of the risk that are going to be addressed. Maybe not all of the risks that you've identified will meet the draw the line in the sand, and these are the things that are in scope and these are the things that are out of scope. Right now, scoping is something that we do traditionally in testing. We always have that section in our test plan of what's in scope and what's not. So here we're talking about what are the risks that you've identified are in scope and what are the risks that are not. And then you agree on responsibility and budget, you agree on your quality criteria, and then the final one is that you take a look at that test strategy and the scope and the definition. It's documented in some fashion. I go with very light documentation, but it's still documented. And then you take a look at it and see, is this strategy feasible? Is it executable? can I really get it done? Do I have the right resources, the right people, the right tools? And so before you do that final implementation of that risk-based strategy, it's the final step to ensure that you have the correct supporting processes, people, and tool to execute it. So again, in summary, before we move on, a risk-based testing process includes looking at the product and identifying potential areas that the product could fail, analyzing them so that you look at how likely it is that the risk would occur, how harmful would it be if it were to occur, and so you come up with a ranking or a score for each of your product components, modules, feature set, and then you respond to those identified risks by coming up with test objectives and a test strategy designed specifically to say, we're concerned about vulnerabilities and security, and we have this test objectives and these series of tests that we're going to execute in this order using these techniques and these approach, and when we're done and these tests have passed, we have confidence that the product won't fail in those particular areas. That's what we're trying to do in that response. And then we look at the scope, and then we look at whether or not we can actually execute it. So how do you identify your risk from a product perspective? There are a number of ways to do it. One of the ways is to use, that I really like, is to do a risk workshop. And it's sort of like a brainstorming kind of session. It's similar to the requirements gathering sessions or design sessions where you have your business people, you have your technical people, and you're facilitating actually getting requirements done. But here you're actually facilitating or getting risk identified. And so it is a facilitated kind of session. And that is the most helpful way to identify risk, because if you've got the architect, you've got your engineers, you've got your security people, you have your business people, and you're able to walk through the product asking questions like, well, could we have a failure here? What are the areas you're most concerned about? Where do you think the vulnerabilities lie? So all of these kinds of questions will help you to identify those areas of the product where it could fail. But there are other techniques that also work. Your testing team can have a brainstorming session about the product that you're getting ready to test. And again, thinking about the product, its platform, its language, and whether or not this is a new area for you as a development team. All of those kinds of things will help you to decide areas that you think might be of concern in that product. You can do an incident investigation where you take a look at a similar product and you do an analysis of the kinds of defects that you found when the other application was under test, and that may point you in areas where you need to test for this particular application. You can look at your constraints and assumptions about how that product is going to work, what things have you assumed are going to be working well, and see whether or not they point you into areas, particularly your constraints, in terms of areas that you need to consider for testing. You can look at business scenarios of the product, and again, from the perspective of any scenario that is most highly desired by a customer, or it's a high demand scenario, would be areas that you don't want it to fail, and so those would put you at a higher impact if the product were to fail in a high demand area versus a low demand or low usage area. So again, all of these different activities help you to really come up with potential product risk areas that would go on your initial list of potential failures. So this is the input into step 2, which is risk analysis, is to identify the product, potential risk areas, and you have that list, and then they go into your risk analysis. So how are some other techniques to look at that product and assess whether or not there are potential areas of risk? Two that I like are what I call inside out and outside in. So inside out is sort of like white box testing. So you're going to be studying the product and asking questions. This is really good for a brainstorming session. This is a really good technique if you've got that facilitated risk kind of workshop going on. And so if you've got a flow chart of the application, if you've got a list of the modules or components or feature sets grouped in some way, you would walk through each one of those areas, the components, the modules, the feature set, and ask questions like, what could go wrong here? Are there any vulnerabilities? Are there any victims? What's the load that could happen? What are the processing errors that could occur? And so these questions would help you to do what? Identify areas that are concerns about in terms of potentially failing. So that's inside out. So if you think about white box testing where you really know what's going on in the testing, that's what's happening here. So the expectation here is that somebody in the room has some idea of how this application is supposed to work or design or be architected, and that will help in terms of you getting the right questions asked so you can identify potential areas that you want to focus increased testing on, because if that area were to fail, that you're really concerned about it. The outside in is a different approach, and you begin with a set of potential risks and you use them as checklists. So right now, for instance, if you're doing a web application, if you were to do a search on the most common defects in web applications, you come up with a hit list. If you were to come up with a search for the most common errors in C++, the most common .NET errors, each platform or language have common kind of defects that you see. And so the outside-in approach is you take those checklists, and I've got one coming up to show you. You take these checklists and you ask, for this module or for this component or for this application, could this be a problem? And if the answer back is, that could be a problem, we might want to test that area more. Then you again have your potential list of candidates. But whether you do an inside out, whether you do an outside in, whether you do scenarios, whether you do defect analysis, whether you do a formal risk identification workshop, in the end of the identification phase, you want to have a list of either features, components, modules, or areas of the code that you are concerned about, that either there's a high probability that they could fail, or there is a high impact or consequence or harm should they fail. And those are then the input into your risk analysis step. So here on the screen is the checklist. That's what I was talking about in terms of the outside-in approach. This is one based on common defects or problems with most applications. I don't know what's happening here in terms of my screen, but so if you see the list, it has like heavily used modules, very complex modules, modules that have been fixed or updated often, high availability functions, functions requiring consistent performance levels, functions using new tools and languages. I won't read them all, but these are commonly occurring areas where we have seen an increased number of defects in either the module or the component. So this checklist allows you to look at Module A, Module B, C, or D, and notice we went through and we answered each one of the questions, giving it either a 5, or it's highly likely that this would be a problem, or this is a very complex one, or low complex one. And so we ended up with either a score of 0, that wasn't really applicable, for instance, like to Module B, and like Module C, very complex, the answer was no, it's low complexity. And so we ended up at the bottom, each one of the modules has a score, 35, 17, 33, and 44. So in terms of your risk strategy, you could say, okay, 44 and 35 and 33 are all high numbers, so these 3 modules will have a high risk focus area in terms of our strategy, and Module B, which has a lower number of risks using this scale, would have a low risk type of strategy in terms of the approach we're going to take for testing. So what these checklists do is they help you to have ideas to think about or assessing the product, so that you can, again, come up with potential areas of the code that you are concerned about from a focus area for focusing your testing. So the areas that there's a higher probability that there would be a lot of bugs, like a more complex module would stand out using this kind of checklist. But again, there's tons of checklists that you can use to help you to identify potential failure points. So the end of risk identification is that you should have some set of product areas or components or features that you are concerned about that you want to focus potentially your testing on. Then you analyze those risks. So now we've moved to step 2 in the product, in the risk-based testing process. So we've identified risk, we used our checklist, we used inside out, we used outside in, we had a workshop, and now we've got 20, 50, or 100, depending on how large your project is, potential areas that you're concerned about failing. So now you do what we call the analysis. And so you look at each one of those risks and you try to come up with a chance or likelihood that the product would fail. So what's the likelihood that module A is going to fail in this way? And then you give it a ranking of high could be 5, moderate could be 3, low or not really concerned about could be a 0 or could be 1. And then you ask, and if it were to fail, how much damage would occur? And so if it's high impact or high visibility to the customer, then that would be a 5. If it's moderate impact or moderate harm or moderate visibility or moderately used in the application, then you would give it a 3. And then if it's low impact or negligible harm or not really visible in terms of the functionality, then it would be a 1 or a 0. And you take these two numbers, the number associated with probability, the number associated with impact or harm or visibility, and you come up with an exposure or ranking. So let's say security vulnerabilities was a high, it was 5. The impact or harm, if be hacked, was high, and so you'd have a 5 times 5, and that would give you a ranking of 25. Using a 5-point scale, no risk would get a higher score than 25, and the lowest score would be 0 or 5 if you're giving them a 1. And so everything then gets what? In a rank or prioritized order, so then you can, the end result of your analysis is that all of the identified product risks that came out of step 1 identification have a number or ranking associated with it. And now you're ready to go into step 3, which is risk response. So when we talk about risk response, we're going to be talking about, on the far right of the screen, product risk. So any risk or issue that is associated with the potential for the product to fail. We're going to have to include those, or we want to include those in our risk-based testing strategy. Oftentimes in these sessions, people will throw out risks that aren't related to the product. They could be a process-related risk, they could be a project-related risk. If those do come up, clearly you don't want to throw them away. You would then come up with a mitigation plan. They would be turned over to your project manager potentially, and they would be monitored the way that any of the project-related risks should be monitored and executed. But any risk that's associated with the product actually failing or not executing the way that it should would be included in your risk-based test strategy. So this is clearly where we make the distinction between process and project risk go into that risk-based test management bucket, and product risk, the fear that the product could actually fail, goes into the risk-based test strategy bucket. So how do you actually then take these risks and then come up with a risk-based testing strategy? When we talk about a risk-based testing strategy, we're talking about creating a custom strategy based on the identified product risk or the areas in your product that you are concerned about failing. And that strategy, the key takeaway for today is that the strategy that you come up with should be designed to find problems as soon as possible. Because we know that we don't have all the time that we want. We know that we often run out of time. And so clearly we don't want to have a risk-based testing strategy or any test strategy that allows us to get through and you've run out of time and the most important risks, the areas that you're concerned about failing the most, have not been adequately tested. If you're going to run out of time, we want to run out of time on projects or product areas where there's low impact if it doesn't work. There's low probability of it failing. But so that strategy that you're going to come up with has to be designed in such a way that you find problems as soon as possible, and you find the most important problems as soon as possible or as early as possible. There's some other benefits that can be gained from a risk-based testing from the goal perspective. It's very helpful in helping you to find problem areas that need the most rework. Again, the analysis that you're doing, that's a potential benefit that could come from a risk-based testing strategy. If you've associated with or identified the benefits that the customer or the ultimate end user is hoping to gain from that release or that product, and those benefits are associated with particular areas of the code, like they are really interested in the interface between the front end and the back end because they want to have a reduction in inventory, then anything any part of the application that directly supports that benefit of inventory reduction would be considered a high priority in terms of your risk focus area. So then you could be able to then say that the inventory reduction feature has been successfully tested, and that benefit, if we were to stop testing now, could be delivered safely without us concerns about significant failures going forward. If you have your quality targets defined, then as you begin to do your risk-based testing strategy, and you've also ensured that the quality targets are a part of that risk-based testing strategy, then the expectations for quality, the status of the expectations for that product quality relative to maybe reliability, relative to functionality, performance, any of those quality characteristics that are part of your strategy could also be reported on. So when we talk about a risk-based testing strategy, we're saying that we customize our test strategy so that we can find the most important problems or bugs as early as possible, and we can provide you with some information about benefits that the product is ready to deliver based on your testing, and you should be able to find some indicators about the quality expectations if those are also included as a part of your test strategy. So how do you get to this risk-based strategy? So you've got a list of product risk. You've analyzed them and they're ranked in descending order from 25 if you've got a 5-point scale, from whatever number if you have a different scale. So you take each one of your product risk. You take a look at the quality characteristics. And I actually have people rank the quality characteristics. It's very hard to do all of them at the same time. If you look at the ILIDs associated with software quality, there's such things as reliability, dependability, performance, security. And so I usually ask for the top 3. And let's say if there's performance and reliability and security are your top 3, you're going to have a different test strategy if those are the 3 most important quality characteristics than if they said that there was maybe performance and functionality and usability. You would have a different strategy. So those quality characteristics are very essential in determining some factors of the strategy that you're going to be employing for that application under test. So you review your product risk, you review the quality characteristics, and then based on the risk and your quality requirements, you begin to identify what you're going to test, and the very essential question, how much? And the approach that I take in terms of how much is that any product area that is a high risk area, I have much more extensive testing than areas of the code that are considered low risk, or all the rest of the code, for instance, that doesn't make it in the risk paradigm. And so that how much, so my strategy might say high-risk areas will be tested with 5 different testing techniques. Maybe we'll also do some more formal testing. But you expect to see, looking at the strategy, significantly more testing, more in-depth testing for higher risk areas, and less testing and less involved testing and less in-depth testing for lower risk or for the remaining areas of the code that do not meet or not included in your risk categorization or your risk matrix. Then for step 3, once you've identified what your focus areas are and how extensive the testing is going to be on your focus areas, then what are the types of testing that you're going to use and when? And I say when because especially if we're on Agile projects, a lot of testing is done during unit. Maybe you're doing code reviews, maybe you're doing peer reviews, maybe you're doing pair programming. There are lots of techniques that would provide some input in terms of quality that may not necessarily be when it gets in the hand of the tester. So if you remember, the risk-based testing goal is to what? Find the problems as soon as possible, so the earlier that we can do some of these techniques, the better it is. And then finally, what are the testing techniques that are going to be used? So when you've done step 1, 2, 3, and 4, then you have the elements to write now your risk-based test strategy. And I do use lighter test documentation, but you can use your more traditional test documentation for your risk strategy. What you would add into your traditional test plans would be a section on risk, so that you talk about your risk identification and analysis approach. And then when you do the test strategy, you would indicate that this is a risk-based test strategy. You would list the risks that you've identified, and then you would identify what is the strategy for high risk, what is the test strategy for moderate product risk, what's the test strategy for low product risk, and what's the strategy for the rest of the application in terms of testing. So one of the things that's really important in this strategy is testing techniques. What I found for risk-based testing, especially if the goal is to identify what? The most important problems as soon as possible, you have to have a more extensive, a broader approach to testing. So I employ a larger number of tests for my higher risk areas and testing techniques. And to give you an example, for high risk, I may have some formal tests for very complex areas where I do the formal traditional test design where you say, you know, input this, see this, this is the expected results, pass or fail. So I may have some subset of the code would have very formal, very traditional testing. I would typically have exploratory testing, because if we're trying to find the most important problem as soon as possible, that technique is a technique that we've determined is very good at finding the kinds of problems that you run into production earlier than more traditional requirement-based testing. So I would have exploratory testing. I may have some formal testing. I may have checklist-driven testing. I may have mainline stream testing. And so I would have multiple testing techniques associated with my high-risk areas. Again, I'm trying to hit it hard because I want to do what? Find out as soon as possible whether or not I should be concerned about this area or not. And then for your lighter or lower risk areas or the rest of the app, I may use exploratory testing as a way to evaluate whether or not it's as solid or the risks are as low as we think they are. And the expectation is that if you do that high-level scenario, let's explore and execute basic activities within this application, if you start seeing problems that you didn't expect because this is a low-risk area, then that means that you need to do what? Adapt your testing strategy. So again, when I finish with my risk-based test strategy, I typically will have 3 to 4 focus areas. A focus area for high risk, a focus area for moderate risk, a focus area for low product risk, and then a focus area for the rest of the application, because clearly we don't want a strategy that doesn't consider the rest of the application, even though we consider that it's a lower risk area. So a good risk-based test strategy should be risk-focused. So again, you've identified your risk, you've analyzed and ranked them, and now you use that information to create risk-focused areas. It should be diversified. That's what I was talking about in terms of the testing technique. We found that the greater the variety of testing techniques and approaches that you employ, the higher the probability that you will uncover those interesting kinds of defects. We're not looking for, remember, the goal of testing is to do what? Find areas of the code that's not working. And so we don't want the vanilla kind of, the screen is blue, I'm testing to see if it's blue, but we're doing all kinds of things, and maybe we're going to also check to see if it's blue because it's supposed to be blue, but we're also going to be trying some other things to really ensure that this product is working the way that it's supposed to be working in these higher risk areas. So we found that diversity in terms of testing techniques and types of testing is what provides you with that ability to do that. And when I say based on maturity, again, we found that if you found a strategy that really works as you begin to use your risk-based approach, you're going to find that certain kinds of techniques work for your web applications. Certain kinds of techniques work really well for maybe for your Agile projects. So as you identify those techniques, you want to make sure that you mature them, and then they become a standing part of what your ongoing strategy. And it should be practical. There's no point having items in your test strategy that aren't feasible to execute, that take too much time to do, and in the end don't result in answering the question. Because the questions that you're trying to answer with a risk-based testing strategy is, are the areas that I'm concerned about failing, are the areas of the product that have a high potential or damage or consequence harm if they should fail? What information do I have based on my test results to reflect whether or not there's a high chance that it could fail or not? So we need practical kinds of approaches that give us those kinds of answers, as soon as possible. And it should be product specific. We don't want a generic approach. This is a risk-based approach based on this product. And so that was the whole point of doing the product analysis when we did the risk identification, is to walk through that product, its architecture, its platform, its design, and ask yourself, based on that it's .NET, based on that it's Java, based on that it's C++, based on that it's client server, what are the things that I need to be concerned about in terms of potential failures? And so that product specific will help you to identify the risk areas and allow you to do the risk focus, make it very diversified, and in the end then you would have a strategy that will answer the questions regarding the potential for this product to fail. So when we're looking at that strategy that we've come up with, and we want to take a look at it and evaluate it to see whether or not it's implementable or not. This is, again, we're down to step 5 in Gerard and Thompson's process. So you're going to be evaluating your test strategy, looking at the resources, the people, the skill set, and the tools in the light of, can they actually accomplish what's needed for this strategy? You're going to identify any training needs to support that strategy. The first time you do a risk-based strategy, your team probably needs to have some training on this new approach. So ensuring that the resources have the right skill set in place to execute that strategy. Are all the tools and products in place to support the strategy? Do you need any new tools, any new products to get this strategy executed? Does the strategy use all the available resources? Have we considered whether or not there's certain kinds of evaluation or testing that can be done by the development team? Can the business people or the product people or the support people provide any expertise or help as we begin the life cycle for testing this product. And the most important question of all, is everything in the strategy necessary? Remember, the goal of risk-based testing is to find the most important problems as soon as possible. And so you don't want a strategy where you have things in just because you're covering the bases. We don't want a covering the bases strategy. The part of the risk-based testing that's really important is once you develop this strategy and as you execute it each day, you're going to be looking at the results that you're getting. And those results would indicate whether or not the strategy stays the same or whether or not the strategy needs to be adjusted. You know, if you've got a moderate area that you're testing and it's showing a lot more severe defects than you thought it would based on it had a moderate risk area, then clearly something's going on in the product, and clearly maybe it should have been a high risk area rather than a moderate risk area. So you do what? You adjust the strategy. But part of what you want to evaluate is to make sure that you've got the leanest, tightest strategy in place to do what? Answer the questions as soon as possible, whether or not there's potentials to be concerned about this product failing. So we're going to be balancing risk versus time. It's an age-old dilemma. It hasn't gone away even with doing the concept of risk-based testing, but you're going to be balancing the testing time that you have allocated up against the risk that you have and the results that you're seeing. And so you do want to have a consensus from the team on how much testing. Is everyone in agreement with what is tested? Does the strategy explicitly say what will be tested and what won't be tested? I have had in my testing contract statements that said that we would only test low-risk areas or certain other areas of the code if time allowed, because you want it very, very clear for the team, for the end user, whoever has to sign off on your results or whoever is accountable for your test results, explicitly what will and what will not be tested. Very similar to what we do currently now, that we statements that say things like we won't do performance testing or the scope doesn't include that. So we want to make sure that we know what is the expectation of good or quality from the test, so that when we report on it, we can say whether or not we have met those targets of good or quality, whatever the quality expectations of that product that's undergoing testing needs to meet. And we want to know that the risk approach that we come up with is known and accepted and bought into by everyone that are key stakeholders in that process. So we're at the last slide. I want to go back over the steps before we take any questions. But again, so a risk-based testing process assumes that you have a product that's under test and you want to identify specific areas of the product that are prone to potential failure. And you can do that using checklists, you can use workshops, you can do defect investigations, you can do scenarios, but in the end of risk identification, you should have a draft, register, or list of potential failure points in that product by component or feature set or etc. Then you do traditional risk analysis where you talk about the risk and you look at how likely the product would fail, and if it were to fail, the damage or harm or consequence. Whatever rating you assign to those, you multiply them and you come up with a exposure or ranking for each product, feature, or module or component. And then you take that list, and I sort of draw a line in the sand. If I'm doing a 25-point scale, I may say everything that's 19 to 25 is high. Everything that's 15 or 13 or 14 to 18 is moderate. Everything under 9 is low. And so you need to bucketize your high, medium, and low risks so that you will be able to then come up with your focus areas. So you would have test objectives associated with each one of your focus areas, and you come up with your testing techniques, you come up with your dependencies. Your traditional test planning kinds of activities do not go away because it's a risk-based testing strategy. And and you agree on the scope of the risks that are going to be addressed. You agree on your quality target that's associated with your risk-based strategy. Then you make sure that it's a feasible strategy that can be implemented, and then you begin to execute that strategy. Again, each day that you execute a risk-based strategy, you look at your test results to see, do I keep the strategy as it is, or do I need to change my strategy because the data is indicating that the risk identified are either correlating with your strategy for high, medium, and low, or the data is suggesting that some other areas are higher risk or lower risk than you identified, and you need to adjust your strategy going forward. So I'd like at this point to see if there are any questions before, I think we've got about 5 more minutes. So Eric, I don't see any questions right now. Hold on, let me go to the question screen.
Yeah, while we're waiting for attendees to submit some questions, can you just go maybe one or two typical questions that you receive when presenting this webinar?
Typically, the questions I get are about coming up with the strategy. And traditionally, because a lot of times in testing, we've gotten used to, we do sort of like boilerplate test plans. And so you've got a good test plan, and you sort of search and replace the application name, and we don't really look at the application and say, for this application, what should I test and why? And so for me, I found that most people struggle with coming up with a different strategy than the traditional take your test plan and this is what I typically test. And so that I found is the most difficult thing. But if you take your risk and you look at these are the high risk areas, and you look at how would I test that area to be really confident that I don't have, that I have the right kind of information to let me know if it's solidly functioning or not. If you look at each area from that perspective and say, what would tell me whether or not this is working or not, and then write your test objectives that way, it's a lot easier to come up with that specialized risk-based testing strategy than you think it would be. The other thing is that I find I keep a list of testing techniques. Right now, if you Google testing techniques, we used to have just a few. Now there's tons of testing techniques. So if you have a list of testing techniques handy as you begin to come up with your strategy, I found it's helpful for you to then figure out how to plug and play and pull some of these strategies in or techniques in for your different levels of the strategy, because you want to diversify and have a really broad mix of testing activities. Again, because we found that helps you to get to more solid information about the status of that product. I don't see any questions.
Actually, we do have a couple of questions that were submitted.
Okay. Can you read them, because my screen doesn't show them right now?
Sure. One was, could you share one of your risk-based testing implementation with an example?
Yes, I can. What would I do? Send that to you, and you provide it. How would I get it to them? That's the question.
You could send it to me, and I can send it to the attendees.
Great. So yes, so I can share a cleaned up version of a strategy that I implemented. Yes.
Okay. And then one other question was, on your testing scoping, you have the stakeholders to agree on risks to be addressed, budget, and quality criteria. I have the stakeholders sign off on the test strategy to avoid any issues. Do you have the stakeholders sign the test strategy?
Yes, I do. Typically I've got a one-page template for test strategy that I typically use, because I found that too big of documents, the customers don't really like to read tons and tons of documents. So yes, I have a 2-page document that lays out the risk and the high-level strategy, and that's what I get them to sign. And I will say I have had some interesting conversations sometimes getting sign-off, particularly when I have that certain areas of the application may not be tested. But I have found that in those instances, if you put if time allows, then the customer will sign off because they understand that you might run out of time. But I struggle with, I don't want to sign and say that I will do test areas that it's possible that we might not be able to get to depending on the allowance of time. But so the short answer is yes, I do have a signature on the template, and the example that I will send will be using that one-page template that I typically use for my risk strategies.
Wonderful. Well, that looks like all the questions that were submitted, so I want to thank you, Clenice, for your time today. And I want to thank everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. Be sure to join us for the next webinar in the series, Identifying and Executing the Most Important Tests, on July 8th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to psqtconference.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us, and have a great day. Thank you, Clenice.
Thank you.